delivering quality education, expanding access to learning, serving learners' learning needs, tackling challenges of the present time, supporting every learner's dream, reaching young Tagumeños where they are today. From the music capital of the Philippines, advancing in the challenge of distance learning. Bringing you quality education straight to your home. Plug yourself in. This is DepEd TV. Tara na!
Good day, grade 11 students. We are here again on our week 2 episode of LANTAW COMPRE featuring General Mathematics. I am your teacher, Teacher Rotzberryl H. Aquilam. Are you ready to learn more? Let's start! Welcome to the General Mathematics grade 11 Alternative Delivery Mode module on solving rational equations and inequalities. The hand is one of the most symbolized parts of the human body. It is often used to depict skill, action, and purpose. Through our hands, we may learn, create, and accomplish. Hence, the hand in this learning resource signifies that you, as a learner, is capable and empowered to successfully achieve the relevant competencies and skills in your own pace and time. Your academic success lies in your own hands. After going through this module, you're expected to: first, apply appropriate methods in solving rational equations and inequalities. Second, solve rational equations and inequalities using algebraic techniques for simplifying and manipulating of expressions. And third, determine whether the solutions found are acceptable for the problems by checking the solutions. Before we head on to our lesson, you will answer a pre-test. Don't worry, your scores will not be recorded. This is just to check how far have you gone in our lesson today. Here's the instructions. Choose the letter that bears the correct answer. Write your answers on a separate sheet of paper. Do not leave any item unanswered. You have 5 seconds for every item to answer. Did I make myself clear? If so, let's start. Question number 1. Which of the following expressions is an equality between two expressions containing one or more variables? A. Rational function. B. Rational equation. C. Rational inequality. D. All of the above. The correct answer is letter B, rational equation. Number 2. What do you call a root obtained in the process of solving an equation which looks correct but after analyzing it turns out as incorrect? A. Extraneous solution. B. Rational expression. C. Least common denominator. D. Quotient. The correct answer is letter A, extraneous solution. Number 3. What do you call an inequality which involves one or more rational expressions? A. Rational function. B. rational equation, C. Rational inequality, D. Irrational expression. The correct answer is letter C. Rational inequality. Question number 4. Refer to the rational equation x over 3 plus 1 over 4 equals x over 2. What is the LCD of the denominator 3, 4, and 2? A. 3, B. 6, C. 8, D. 12. The correct answer is letter D, 12. Number 5. What property will be used if you multiply the LCD on both sides of the equation? A. Distributive property, B. Associative property, C. Commutative property, D. Additive property. The correct answer is letter A, distributive property. Number 6. What will be the new form of the equation after applying the property and simplifying? A. 4x plus 3 equals 6x. B. 3x plus 4 equals 2x. C. 6x plus 4 equals 3x. D. 12x plus 3 equals 12x. The correct answer is letter A. 4x plus 3 equals 6x. Number 7. What will be the solution on the given rational equation? A. 2/3, B. 3/2, C. 2, D. 3. The correct answer is letter B, 3/2. Question number 8. How will you check if your solution is correct? A. By eliminating the rational expression. B. By dividing both sides of the equation by LCD. C. By applying commutative property. D. By substituting the answer or solution in the original equation. The correct answer is letter D, by substituting the answer or solution in the original equation. Question number 9. Which of the following is not an inequality sign?
A. Less than or equal to. B. Square root. C. Greater than or equal to. D. Less than.
The correct answer is letter B. Question number 10. Express the graph of solution set into interval notation.
A. The set of all x such that x is any number greater than or equal to -3 and less than 1. B. The set of all x such that x is any number greater than or equal to -3 and less than or equal to 1. C. The set of all x such that x is any number greater than 3 and less than or equal to 1. D. The set of all x such that x is any number greater than or equal to 3 and less than 1.
The correct answer is letter A. Good job, class! I knew you could do it. Welcome once again to Lesson 1 of Module 6 in the first quarter of Grade 11 General Mathematics. Solving rational equations and inequalities. This time, let us have a review. How do you solve algebraic expressions? What are the different properties you need to apply to solve problems involving rational equations and inequalities? For you to begin, you need to recall some properties and processes to simplify rational expressions by answering the following problems on the screen. Number 1. Simplify the rational expression x minus 2 over x squared minus 4. Number 2. Multiply the rational expressions 3x plus 1 over x squared minus 1 times x plus 1 over 3x squared plus x. Number 3. Find the sum of the rational expressions with like denominators. 5x minus 1 over x minus 8 plus 3x plus 4 over x minus 8. In number 1, to simplify the rational expression, you can do the following steps. A. Factor the denominator of the rational expression x minus 2 all over x minus 2 times the quantity of x plus 2. Letter B. Cancel the common factor, which is x minus 2. Letter C. Write the simplified rational expression. Our answer is 1 over x plus 2. Number 2. To multiply rational expressions, do the following steps. A. Factor out all possible common. 3x plus 1 over x plus 1 times the quantity of x minus 1 times x plus 1 over x times the quantity of 3x plus 1. Letter B. Multiply the numerators and denominators. So this becomes the quantity of 3x plus 1 times the quantity of x plus 1 all over x plus 1 times the quantity of x minus 1 times x times the quantity of 3x plus 1. Letter C. Cancel out all common factors. In this case, we will cancel out 3x plus 1 and x plus 1. Letter D. Write the simplified rational expression. So our answer is 1 over x times the quantity of x minus 1. Number 3. To add and subtract rational expressions with like denominators, you can do the following steps. A. The numerators of both expressions and keeping the common denominator. 5x minus 1 plus 3x plus 4 all over x minus 8. We need to combine like terms in the numerator. So this becomes 5x plus 3x plus 4 minus 1 all over x minus 8. Letter C. Write the simplified rational expression. So our answer is 8x plus 3 over x minus 8. How was the activity? Did you answer all the items correctly? Great! Then you can now forward on the next stage of this topic. And I am confident that it will be very easy for you to understand the lesson. Remember, learning mathematics is a linear process wherein the math skills and knowledge from the previous modules and grade level will be used throughout this topic. Before we proceed on the lesson proper, try to answer the rational equation and inequality. I will be giving you the guided procedures for you to follow. Example number 1. First, find the least common denominator. Our LCD is the quantity of x plus 5 times the quantity of x minus 5. Second, multiply both sides of the equation by its LCD. So from our original equation, we will multiply our LCD, which is x plus 5, times the quantity of x minus 5. Third, apply the distributive property and then simplify. Simplify 2x minus 8 equals x plus 5. We will combine like terms, so this will become 2x minus x equals 8 plus 5. The value of our x is equal to 13. Fourth, find all the possible values of x. In this case, the value of our x is 13. Fifth, check each value by substituting into original equation and reject any extraneous root. In this case, from its original equation, we will substitute the value of x, which is 13. We will perform the operation, and our answer is 1/8 equals 1/8. Therefore, we don't have extraneous root. Number 2 example is inequality. Given that 3 over x minus 2 is less than or equal to negative 1. First, put the rational inequality in general form. R of x over q of x is greater than 0, where greater than can be replaced by less than or equal to, and greater than or equal to. Second, write the inequality into a single rational expression on the left side. So this will become 3 plus x minus 2 over x minus 2 is less than or equal to 0. Third, set the numerator and denominator equal to 0 and solve. The values you get are called critical values. For our numerator, x plus 1 equals 0, so the value of x is equal to negative 1. For our denominator, x minus 2 is equal to 0, therefore, our x is equal to 2. Fourth, plot the critical values on the number line, breaking the number line into intervals. Fifth, substitute critical values to the inequality to determine if the endpoints of the intervals in the solution should be included or not. In this case, we have our original equation, 3 over x minus 2 is less than or equal to negative 1. When x is equal to negative 1, we will substitute negative 1 on our original equation. This becomes 3 over negative 3 is less than or equal to negative 1. Our answer is negative 1 is less than or equal to negative 1, which is correct. Therefore, x equals negative 1 is included in the solution. When x is equal to 2, and by substituting 2 to the original equation, we would get 3 over 0 is less than or equal to negative 1. And we all know that all numbers divided by 0 is undefined. Since our answer is undefined, therefore, x equals 2 is not included in the solution. 6. Select test values in each interval and substitute those values into the inequality. Note, if the test value makes the inequality true, then the entire interval is a solution to the inequality. If the test value makes the inequality false, then the entire interval is not a solution to the inequality. So when x is equal to negative 2, we would get 3 over negative 4 is less than or equal to negative 1, which is incorrect. So our answer is false. When x is equal to 0, we would get 3 over negative 2 is less than or equal to negative 1, which is correct. So our answer is true. When x is equal to 3, we would get 3 is less than or equal to negative 1, which is incorrect. So our answer is false. 7. Use interval notation or set notation to write the final answer. Our final answer is negative 1, 2. How do you find the activity? Have you enjoyed it? Did you follow the steps correctly? The activity tells you about solving rational equations and inequality. Rational equation is an equation containing at least one rational expression with polynomial in the numerator and denominator. It can be used to solve a variety of problems that involve rates, times, and work. Using rational expressions and equations can help us to answer questions about how to combine workers or machines to complete a job on schedule. This time, let us deepen your knowledge and skills in solving rational equation by solving more. What's the first thing that comes into your mind in solving rational equation? Correct. It is to eliminate all the fractions. Now, let us solve. Our equation is 2 over x squared minus 1 minus 1 over x minus 1 equals 1/2. Step 1. You need to find the least common denominator. The LCD of the given fraction is 2 times the quantity of x minus 1 times the quantity of x plus 1. Step 2. You need to multiply the LCD to both sides of the equation to eliminate the fractions. To solve, we have 2 times x minus 1 times the quantity of x plus 1 times the original equation.
Step 3. You simplify the resulting equation using the distributive property and then combine like terms. In this case, we have 2 times 2 minus 2 times the quantity of x plus 1 equals x minus 1 times the quantity of x plus 1. By performing the operation, our resulting equation is x squared plus 2x minus 3 equals 0.
Step 4. You need to solve the simplified equation to find the values of x. In this case, we need to get the equation equal to 0 and solve by factoring. So from the simplified equation, which is x squared plus 2x minus 3 equals 0, the factors are x plus 3 and x minus 1. If we will equate each factor to 0, the values of x are negative 3 and positive 1. So the possible solutions are negative 3 and 1. Step 5. Finally, you can now check each solution by substituting in the original equation and reject the extraneous roots. To solve, we have when x is equal to negative 3, we will substitute negative 3 to the original equation. And then we will find out that 1/2 is equal to 1/2, which is correct. When x is equal to 1, we will substitute 1 to the original equation. And we found out that which is incorrect. In this case, x equals -3 is the only solution. That's why it is always important for us to check all the solutions in the original equation. Let us proceed to rational inequality. Rational inequality is an inequality which contains one or more rational expressions. It can be used in engineering and production quality assurance as well as in businesses to control inventory, plan production lines, produce pricing models, and for shipping and warehousing of goods and materials. Solving an inequality is much like solving a rational equation, except that there are additional steps that focus on illustrating the solution set of an inequality on a number line. Let's have an example. Solve the expression 3x plus 1 over x minus 1 is greater than or equal to 2. Step 1. Put the rational inequality in the general form where greater than can be replaced by less than, greater than or equal to, and less than or equal to. So to solve, we have r of x all over q of x is greater than 0. So from our original expression, this becomes 3x plus 1 all over x minus 1 minus 2 is greater than or equal to 0. Step 2. Write the inequality into a single rational expression on the left-hand side. We will perform the operation on the original equation. So it becomes 3x plus 1 minus 2 times the quantity of x minus 1 all over x minus 1, which is greater than or equal to 0. So the resulting expression is x plus 3 all over x minus 1 is greater than or equal to 0. Remember that one side must always be 0 and the other is always a single fraction. So always simplify the fractions if there is more than one fraction. Step 3. Set the numerator and denominator equal to 0 and solve. The values you get are called critical values. To solve for the numerator, we have x plus 3 equals to 0. Therefore, the value of our x is -3. For our denominator, we will equate x minus 1 to 0, which becomes x equals 1. Step 4. Plot the critical values on a number line, breaking the number line into intervals. Step 5. Substitute critical values to the inequality to determine if the endpoints of the intervals in the solution should be included or not. So from our original expression, we will substitute -3. This becomes 2 is greater than or equal to 2, which is correct. Therefore, -3 is included in the solution. And now we will substitute 1 to our original expression, which will give us undefined is greater than or equal to 2, which is incorrect. So therefore, 1 is not included in the solution. Refer to the illustration shown. Step 6. Select test values in each interval and substitute those values into the inequality. When x is equal to -5, we will now substitute -5 on our original expression, which will give us 7/3 or 2.33 is greater than or equal to 2, which makes -5 true. If we will substitute -1 to our original expression, we have 1 is greater than or equal to 2, which is incorrect. So therefore, -1 is false. Now we will now substitute 3 to the original expression. Our answer is 5 is greater than or equal to 2, which is correct. So therefore, x equals is 2. Note, if the test values makes the inequality true, then the entire interval is a solution to the inequality. And if the test value makes the inequality false, then the entire interval is not a solution to the inequality. Step 7. Use interval notation to write the final answer. Our final answer is the union of -infinity to -3 and 1 to infinity. That's it! For more examples, kindly refer to your module on page 14. To assess your understanding about solving rational equations and inequalities, kindly answer assessment of your module on page 21 on a separate sheet of paper. We will be collecting all of your answer sheets by the end of the week. Another session has ended. I hope you learned a lot from today's lesson. See you all in the next episode of our LANTAW COMPRE School on Air Through Television. Once again, I am your teacher broadcaster, Rotzberryl H. Aquilam, saying, to learn mathematics is to do mathematics.